Welcome to the Deep Dive, your shortcut to being genuinely well-informed. Today, we're plunging into a headline that honestly stopped me cold. 96% of world's oceans are burning. I mean, what an image, right? It's dramatic and, frankly, terrifying. Our mission, as always, is to cut through the noise. We sift through your stack of diverse sources, everything from scientific journals to global news outlets, and we pull out the most important nuggets of knowledge custom-tailored just for you. So we're embarking on a journey through some incredibly complex, really critical information to help you truly understand what's happening beneath the surface of our planet.
Yeah, that's exactly right. The core focus of this deep dive is, well, understanding these unprecedented changes happening in our oceans and the profound long-term implications these shifts could have for the global climate. We'll look at not just what the science is telling us, but why it matters to every single one of us. We're connecting the dots between these crucial scientific findings and the broader global headlines that are, shaping our world.
Okay, let's unpack this then. This headline about oceans burning. It isn't just hyperbole, is it? Your sources reveal a pretty startling reality from 2023. We're talking about unprecedented marine heat waves, MHWs they call them, affecting a staggering 96% of the world's oceans.
96%. It's almost unbelievable.
Right, that's nearly every ocean basin on Earth. And these weren't just widespread events. They set new records for both their intensity and, crucially, their duration. Can you imagine this? In some areas, like the North Atlantic, these heat waves lasted an extraordinary 525 days.
525 days.
Yeah. Picture what such sustained, intense heat means for all the life in our oceans. It paints a really, really dire picture.
It absolutely does. Marine heat waves are essentially, well, periods where ocean temperatures rise significantly above their normal levels. And they stick around for extended durations, often weeks or even months. And the consequences, as you highlight, are profound and far-reaching. One of the most visible impacts is widespread coral bleaching. Coral reefs, people often call them the rainforests of the sea, right? They're vital habitats. They support maybe a quarter of all marine species.
A quarter? Wow.
So when temperatures get too high, the corals expel the symbiotic algae they need for food. They turn white. And, well, ultimately they can die if the heat just doesn't let up. This isn't just about losing something beautiful. It's a systemic disruption.
Systemic?
Yeah. Many fish and marine organisms are highly sensitive to these temperature shifts. Their habitats become inhospitable. This then impacts crucial breeding cycles. It alters migration patterns, disrupts feeding habits. You get this cascade effect through the entire food web.
The cascade effect. Okay.
And what's more, increased ocean temperatures also lead to reduced oxygen levels. So it's like a double whammy. It creates this dual threat to aquatic life that just makes everything worse.
So it's far beyond just, visible destruction. It sounds like a systemic ecological breakdown. And I'd imagine there's a significant economic fallout from this too, isn't there?
Indeed. Oh, absolutely. The economic impact on fisheries alone, for example, could reach billions of dollars globally. Just think about communities worldwide that rely on these marine resources for their livelihoods. From small-scale fishing villages right up to large commercial operations.
All right.
Disruptions to fish populations mean income loss, food insecurity, pressure on local economies. These events present an urgent need for adaptive management strategies, not just ecologically, but socioeconomically for countless coastal communities and nations.
That's a profound impact, touching both ecosystems and economies. Now, when we see these kinds of extreme events, the immediate question is always, is this just a natural cycle playing out, or is there something, bigger going on here?
It's a complex interplay, definitely. But there's a clear human signature. On the natural side, sure, we do see regional drivers. For instance, increased solar radiation from reduced cloud cover can play a role. Changes in ocean circulation, altered wind patterns too. And a major exacerbating factor in 2023 was the strong influence of the El Niño phenomenon.
El Niño, right.
Yeah. For listeners maybe unfamiliar, El Niño is a natural climate pattern. Surface waters in the Central and Eastern Pacific Ocean get significantly warmer than normal, and that leads to major shifts in global weather patterns. This natural warming event basically amplified the ocean temperature anomalies, particularly in places like the tropical Eastern Pacific. They saw spikes of up to, I think, 2.9 degrees Fahrenheit recorded there. It added a powerful natural push to the warming trend.
So El Niño acts like a natural amplifier on top of everything else, but You mentioned a human signature. How critical is that part in the context of these massive heat waves?
That's the crucial part, really. While natural factors can contribute, the sheer scale, the intensity, the persistence of these heat waves, it just cannot be explained by natural forces alone. Human-driven climate change has significantly amplified the problem, no question. Our greenhouse gas emissions have steadily raised baseline ocean temperatures. That makes the oceans far more susceptible to these extreme heat events when natural cycles like El Niño come along.
So we've kind of preloaded the system.
Exactly. And this also creates dangerous feedback loops.
Mm.
One big one is increased stratification. Just picture the ocean's layers becoming really distinct, like oil and water. It prevents colder, nutrient-rich water from mixing with the warmer surface layers.
Okay.
This stratification effectively traps heat in the upper ocean. It acts like an insulating blanket. And that further intensifies marine heat waves and reduces vital oxygen.
Yeah.
These interconnected processes, well, they're leading to potentially irreversible changes in the global climate system.
Irreversible changes. That's sobering. Okay, here's where it gets really interesting and, frankly, quite alarming. Because the stakes might be even higher than we just realized. We've talked about how marine heat waves are essentially setting our ocean's surface on fire, impacting everything from coral to, well, our dinner tables. But digging through your sources, another truly unsettling revelation emerged. It suggests the stakes might be even higher, potentially impacting an entire continent's climate. We're talking about a vast, deep ocean system you might not even realize governs your weather. The Atlantic Meridional Overturning Circulation, the AMOC.
That's right, the AMOC. It's fundamental to truly appreciate it. Picture it as this colossal deep ocean engine, almost like a giant conveyor belt. Warm, salty water from the tropics flows northward. It releases its heat to the atmosphere. That's a major reason Western Europe stays relatively mild and habitable.
Right. Keeps London warmer than Labrador, basically.
Exactly. Then as that water cools and becomes denser, it sinks deep into the Atlantic and then flows back south along the ocean floor. This massive density-driven conveyor belt doesn't just move water, it redistributes immense amounts of heat and salt. It acts as a critical regulator of global climate. A single water parcel takes roughly 1,000 years to complete this epic journey.
1,000 years for one trip. That's just a mind-boggling scale, yet it's dictating our weather right now. And your sources highlight a new study about this AMOC system that is, shall we say, not exactly comforting.
Far from it, unfortunately. A new study, this one published in Environmental Research Letters, by researchers from institutions like the Potsdam Institute for Climate Impact Research. It brings a genuinely shocking finding to light. This analysis indicates that the collapse of the AMOC is far more likely than previously thought.
More likely. How much more likely?
Well, co-author Stefan Rahmstorf, he's a leading scientist in this field. He once described the possibility of AMOC collapse due to rising global temperatures at around, say, 10%. Now, he says he might describe it as closer to 25%.
Wow, from 10 to 25%, that's a significant jump.
It's a huge jump. And the study further concludes that the tipping point, the point at which an AMOC shutdown becomes inevitable is likely to be passed within just a few decades, possibly in the next 10 to 20 years or so.
Wait, the tipping point itself could be that soon, within 10 to 20 years. So the commitment to collapse happens much sooner, even if the full shutdown takes longer.
That's the terrifying part, the decision point, if you like. And the science behind this increased risk. It's precisely what you might expect. It's the influx of fresh water into the North Atlantic, particularly from melting ice sheets in Greenland and the Arctic.
All that meltwater.
Exactly. This fresh water is less dense than the salty ocean water, so it kind of sits on top. It forms a layer.
Okay.
And that prevents the warm, salty water from sinking, which is what drives the whole deep return flow south. If this sinking mechanism weakens too much, the entire conveyor belt can slow down, or even shut off completely.
Right.
The study models this process, and it concludes that this tipping point for an AMOC shutdown is dangerously close. Now, the actual collapse itself might not happen until 50 to 100 years later, maybe after the year 2100, the study suggests. But the imminence of passing that point of no return, that's what demands our immediate attention.
That is a dramatic increase in probability and a much, much sooner timeline for crossing that critical threshold. So, okay, what would be the global implications if this vital conveyor belt were to actually shut down? What does a catastrophic climate event really look like in this scenario?
Well, catastrophic is probably the right word. The consequences of an AMOT collapse would be felt worldwide. It would be a fundamental rewriting of the global climate patterns that have shaped human history and agriculture for millennia. For Europe, for example, it wouldn't just mean colder winters. Imagine the mild, predictable climate, the very foundation of its modern civilization, just gone. Replaced by significantly colder winter temperatures, potentially by several degrees Celsius, and much, much drier summers. That's according to the UK's National Centre for Atmospheric Science.
Several degrees colder winters, drier summers, that would force a complete societal reevaluation, not just adaptation.
Absolutely. And globally, the rain belt would shift dramatically. That means major disruptions. Areas currently reliant on predictable rainfall for agriculture. They could face devastating droughts, crop yields would plummet, and it would likely exacerbate extreme weather events across different regions.
And sea levels.
Coastal communities worldwide would also face increased threats from rising sea levels. The disrupted ocean dynamics would mean less warm water stored up in the North Atlantic, and that affects how ocean mass is distributed globally. So sea levels would adjust, likely rising more in some areas.
That sounds like a scenario out of, well, a disaster movie, frankly. Yet your sources are telling us it's becoming alarmingly plausible. I understand some scientists still advise caution regarding the exact probabilities, right? But even they don't dismiss the risk entirely.
That's a vital point. Yes, there is some caution. Scientists like Jonathan Baker at the Met Office Hadley Center in the UK, for instance, they do advise caution, suggesting we need more simulations to really pin down the precise risk. But crucially, they also reiterate that even if a collapse is unlikely, a major weakening is expected, and that alone could have serious impacts on Europe's climate in the decades to come.
So even a slowdown is bad news.
Exactly. The key message is that the risk is far from negligible, and the potential impacts are so profound. We just cannot afford to ignore this warning.
That absolutely underscores the urgency. It sounds like, we have to act really fast because that tipping point could be coming up so quickly. So what does this all mean for us, the listener, living in this rapidly changing world? It's clearly not just about the oceans in isolation, is it? As we looked through your news stack, it became clear these deep ocean concerns are just one piece of a much bigger puzzle. It illustrates the sheer complexity and interconnectedness of all our global systems.
Precisely. It's crucial to see these ocean concerns not in isolation, but as part of a web. Take, for instance, other headlines you found confirming environmental threats, like continental water loss surpasses ice sheets as primary driver of rising sea levels worldwide.
Right, water moving off land.
Yeah. This isn't some separate crisis. It directly contributes to rising sea levels, which then compounds the threats coastal communities face from those altered ocean dynamics we just talked about. It all links up. Or think about the rapid evolution of technology. Major discussions around AI, like Anthropic to pay authors $1.5 billion to settle a lawsuit over pirated books used to train AI chatbots.
Okay, how does AI connect here?
Well, while it seems distant, think about the immense energy consumption needed to train and run these sophisticated AI models. That energy demand, depending on where it comes from, can directly contribute to the very greenhouse gas emissions driving these oceanic changes. It forces us to ask, are some of our advancements inadvertently accelerating our foundational environmental challenges?
That's a fascinating, if maybe sobering, connection. How even developing AI could contribute to the very climate issues it might one day help us analyze. It really highlights how everything is woven together, doesn't it?
It really does. And beyond that, your sources also touch on issues like Singapore leads, with unprecedented enforcement against social media scams, or deepfake, a crisis of trust.
Right, trust in information.
Exactly. These speak to the integrity of information and the stability of our digital societies. Now, while not directly climate-related, think about it. The ability of societies to function, to make informed decisions, to coordinate responses to complex threats like climate change. It relies on trust and accurate information. When that trust is eroded by things like deepfakes or massive scams, our capacity to address any major challenge is diminished.
So a breakdown in trust makes tackling climate change even harder.
It certainly doesn't help. All these diverse issues, from climate tipping points and water scarcity to technological advancement, cybersecurity, global tensions, you name it, they highlight that environmental and human systems are deeply, deeply intertwined. It really demands a holistic understanding and response from all of us.
What a profound and, well, comprehensive deep dive today. We've journeyed from the critical state of our oceans, those unprecedented marine heat waves, to the potential, very real threat of an Ammersee collapse, all set against this backdrop of a globally interconnected and seriously challenged world. Understanding these complexities, I think, is genuinely the first step towards informed engagement and hopefully meaningful action.
And that's the crucial takeaway here, isn't it? Your sources remind us that, quote, the future of the Atlantic circulation is still in our hands. The primary mitigation strategy mentioned, not just for the AMOC, but for so many of these climate-related challenges, is adopting clean, renewable energy At every scale, from individual households right up to national grids, it's about rolling back that heat-trapping blanket of human-caused pollution.
It's a daunting challenge, no doubt, but also empowering in a way. The power of knowledge, even when it presents such immense hurdles, is truly immense. It allows you, the listener, to ask better questions, push for better solutions, and crucially understand the interconnectedness of our world.
Which perhaps raises an important final question for you, the listener, to ponder. In a world facing these unprecedented environmental and societal shifts, how do we balance the immediate pressing needs of human communities today with the long-term existential well-being of our planet's fundamental life support systems for tomorrow?